Okay, this example here is going to be similar to example 3 from the graphing video a couple weeks ago, or a couple days ago, excuse me. I made some changes just to make the algebra work out a little bit cleaner, okay? But once again, that's the reason why I don't like this, this method, is if I don't get a coefficient of either +1 or -1, this method isn't very good. So that's why elimination can handle any type of equation, any type of system when we get to it next week. So if I'm taking a look at the coefficients, I see a +2, a +4. That's not going to be easy to work with because at some point I'll have to divide that out. But I do see a +1x. I'm going to ignore the 2y. So +1x is what I'm going to want to solve for. So I'm going to take equation 2 and rearrange. I want to get x by itself, so I'm going to subtract the 2y. Okay? I'm just writing a 3 minus 2y. I don't need it in slope-intercept form. I'm not graphing it. We're doing this algebraically. Okay? So x is now equal to 3 minus 2y. Now, since I rearranged the bottom equation, I'm going to come to the top equation. So 2x plus 4y is equal to 6. I'm going to replace the x with what we now know x to equal, the quantity 3 minus 2y. Okay, so now I've subbed in. I'm now working with the equation just in one variable. So we're going to go ahead and solve for that variable. We're going to solve for y. We'll distribute in, and 2 times 3 is going to give me 6. 2 times -2y is -4y. Plus the 4y already on the outside, and that's going to be equal to 6. Now, just like in the previous video, the variable canceled out and you got a nonsense expression. -6 does not equal 2. But in this case, the variables cancel out and we're left with a true statement. 6 does equal 6. Okay? So this is infinitely many solutions. Okay, in the no solution case, the lines were parallel and never touched. In this case, it doesn't matter what x and y is, the lines are sitting on top of each other. So every single point is in common. So you have an infinite number of coordinates in common. So we call this consistent dependent. Consistent dependent. So this was exactly the same line. Okay, it's one line lying on top of the line itself.